The world's population is exploding. We're 7.7 billion people on the planet right now. And by 2050, we will be nearly 10 billion people. That's a faster growth than we have ever seen before. Now, more than 90% of those new arrivals, they will want to live, or they will need to live, in cities. Now, our cities are nowhere near ready for this. Think about it. It's like the population of Paris moving in every week, in need of a place to stay. We need to build an equivalent to Paris every single week. Now, that's a lot of buildings. And buildings account for 1/3 of the total energy consumption on this planet, and more than 40% of the global CO2 emissions. So we need to find ways of designing better and smarter and more sustainable buildings and cities. Architects, developers, urban planners, engineers need to be more creative than ever before to come up with ways of building faster and denser than before without reducing the quality of life. So both maximizing the use of space, but minimizing the environmental impact. Now, we are all here in this room and in this conference because we believe that technology can help save this last living dinosaur, right? Can help solve one of the biggest industries of the world, that's the least digitized industry of the world, and it's had a falling productivity since the 1950s. We all believe in that, right? And artificial intelligence is an amazing example of how this can actually happen. It's an example of how architects can get powers that they never had before. That they can come up with patterns and solutions that they wouldn't come up with at a speed that wasn't possible only 5 years ago. Now, I want to be a little bit more specific. 5 years ago, I was working as an architect, and I was given the task to design my dream project. Some urban family houses, apartments and townhouses, a few hundred of those, in an urban site. And urban sites are very complex. So I did what most of you, or most of us do, we consult on experts. And experts are really good in their own fields, like noise calculation, or daylight calculation, or geotechnics, or accessibility, or stormwater flooding, or grocery stores, or landscape design. And the problem is that it makes it really hard to be creative, because it often takes days or weeks to get a report back. But the biggest problem is that the advice that I got was often conflicting, or even contradictory. So the daylight expert told me to put buildings in a way that opened up for more noise on the site. And then the acoustic engineer told me to put buildings in a way that left the entire area in shade. So what I needed was a tool that could do the calculations for me so that I could be creative. Because I was on a limited budget and a limited time, and I had to make bad calls. I had to just pick something, right? I had to just do these bad trade-offs. And we believe that computers are much better than humans to do exactly that, to do the calculations so that humans can be creative. Because computers love complexity. They love calculating stuff. And they can find patterns in these huge data sets. And they're neutral. They don't represent one of the stakeholders around the table. They can discover the intelligent trade-offs, right? The best possible solutions. And that's what it's about. And at Spacemaker, we have built this product. We're a group, we've managed to put together a group of close to 100 amazing people. We're spread across US and Europe. And you will get to meet one of them very soon, one of our data scientists, and she will give you a sneak peek under the hood of the technology. But she will also show you the product that we've built that made it possible to use this technology without having PhD in math from Harvard, right? Because as an architect, I needed a tool that was possible to use, and it was self-serviced. And the tool that she's going to show you is built for residential development, which is where we start. And it's built to be used on feasibility studies, because feasibility studies, the early concept and the design phase, is where the most value can be gained or lost. And what we have learned from the industry using this is that this product can help solve their biggest pains that they tell us. It's about the cost of human mistakes, and it's about leaving money on the table, and it's about having a more professional and transparent dialogue across all stakeholders, including the planning authorities. And we do that by providing them a tool that they can use to do massive testing, to test thousands of proposals, or to optimize their layout, or to do 84 analysis with a click of a button, advanced analysis that used to take weeks to do just one on one proposal. And you will see a variety of topics that Ingvild will show you in a very few moments. But the best part is there's much more to come. These are some of the topics we're working on. One very exciting example is that we're training the AI now across 90,000 apartment layouts. So we're moving inside the buildings. So it's actually learning to generate apartment layouts trained on across 90,000 different apartments. But it's a warm, it's a pleasant, I mean, it's amazing to be able to welcome one of our amazing team members here to give you a look under the hood. Please give a warm welcome to one of our lead data scientists, Ingvild, Lyckander.
Is the sound okay? Great. So I will give you just a brief introduction to the complex problem that I and my colleagues are facing every day. But first, a quick warning. It might be a little tech-heavy for some of you. But don't panic. I don't expect you to understand everything I'm about to say. You're not supposed to try this at home when you get home. So, first, let me give you an illustrative example of how complex the problem we are solving actually is. Let's say that I have 8 buildings with flexible heights at a site 100 meter times 100 meter. The number of combination is mind-blowing. That's a higher number than the number of sand grains at Earth. And if we are supposed to find the best solutions among all these combinations, we need to consider many dimensions like sun, wind, daylight, noise, view, density. And to consider these dimensions for all possible combinations is impossible. Let's look at noise as an example. Today, in a typical project, you would usually order a noise report from an external consultant, and it would probably take weeks before it's done. We have developed an acoustic model which gives you the same accurate detail analysis of noise in 10 minutes on average. But still, 10 minutes on average per solution. To consider all combination would still be an impossible task. Because even if I had all the computer power in the cloud from both Amazon and Google run in parallel, it would still take me more than 3,000 billion years to calculate. So you might think that, okay, we can only consider noise for a couple of solutions. But that wasn't an option for us. noise is not only an inconvenience. Each year, thousands of people die prematurely due to noise pollution in Europe alone. That's why we wanted to optimize for noise, but we had to find a smarter way. So therefore, after extended research, we both find an intelligent way to only consider a fraction of all combinations, the most interesting solutions. And we reduced the time it took to consider a single solution. And now I will show you an example of how we achieved the latter. By using advanced deep learning, we developed a predictive model which reduced the time it took to consider noise at a site from 10 minutes to 0.05 seconds. Development of this model consisted of 3 stages. We had to generate a lot of data sets to learn from. We used this data set to train a convolutional neural network. And finally, we used this trained model in our optimization engine to search for the best solutions. And I will try to give you a short introduction to each of these steps. Because to train a machine learning model, you need something to train on. And for our case, that is a noise analysis for many different projects with different layouts and structures. And analysis is generated from our acoustic model, which took 10 minutes to calculate. But this is a one-time happening, so that's no worries. And here is represented with a heat map of the decibel scale. And the goal here is to feed in thousands of these solutions into the model, and for the model to develop an intuition of how noise propagates at the site by looking at the relationship between the placing of the buildings, the road structure, and the results from the acoustic model. So we used all these thousands of solutions into the training. And here is where we build the intuition of the model, in the model. And I will try to illustrate it. So here we have an example of a site, a project with buildings and a noise source on the top. And below, there's a result from our acoustic model. And to the right, there's a movie where we make predictions to this scenario during the training process. And as you can see, it gets smarter and smarter as more data we feed into the model, even though it has never seen this exact project before. And now we have a trained model with a good intuition, and we will use that in our optimization engine to look for the best solutions. Here in this simplified example, we maximize building volume and we will minimize noise at the ground. The red dots represent the road, and on the bottom left here, you will see the noise level decreasing during the optimization. And if we're about to use the acoustic model that we had before, each little movement or change in the geometry would require a 10-minute analysis. But instead here, we use the intuition of the model and can give information about noise in less than 0.05 seconds. So that was a very brief tech deep dive of something that we work with. And now we will take a look at the product. The first thing you have to do is to set up your project with your desired preferences and constraints. For instance, such as zoning, like minimum and maximum height, or height zones, or import roads and traffic loads. And when you're done with configuration, Spacemaker will search in the enormous solution space for the most interesting solutions, and they are presented here. And you can navigate among the concepts by filtering or viewing trade-offs and tendencies of the qualities. It is also possible to import a self-drawn solution and compare it with the machine-generated ones. And when you find an interesting solution, you simply click on it and you will have 84 analyses available at your fingertips. For instance, density or suggested apartment mix and layouts. You will see how the sun and shadowing at every given date and time. And you can get detailed sun statistics for every facade and every apartment, like sun hours. Another analysis we have is view length. And again, you can click on any apartment and you'll get more detailed insight. There's the noise analysis with decibels on each facade and apartment, and a wind analysis. And we continue to always add new analysis. One thing we launched recently is an early stage approximation of daylight factor, or daylight, shown here with vertical skylight. So this is just a very short and brief introduction to the product. But please come and visit us at our booth for a more in-depth demo.
Okay, you hear me okay again? Yeah, perfect. Thank you. We want to show you how this actually works. What is the users using this for? What kind of value can this be creating in the real world? And we have been partnering with some of the leading residential developers in our region from day one. And some of them are using this now across their entire portfolio. Some are using them on a small amount of projects, but you can see some of the examples here. And what they tell us is what they see in the project is that they see that they can reduce the time spent. They can also reduce the cost spent, but they can also professionalize the dialogue with not only the planning authorities, but with all stakeholders by working with transparent numbers, by fact-based decisions and analysis. And as I mentioned in the beginning, they also see that the computer or the product can discover solutions that pack smarter or discover more efficient ways of increasing the area or the rentable or sellable space without reducing the living qualities. And let me put some numbers on that. One of the largest developers in our region publicly quoted that they'd save a year of using Spacemaker on a project with a few hundred apartments. And that accounts for 1.9 million euros in just capital cost, right? But even if you don't save a year, if you only save a month, that's still 150,000 euros. But let's look at the living qualities. If you improve noise, or if you improve housings with a sea view, or increase in daylight, these three variables, and you increase the sellable area, on these 4 dimensions, just 1% counts for 300,000 euros, right? On an average residential project of 150 units. Now, if you gain 10%, that's 3 million euros. 15% is 4.5 million euros. And I want to give you an example of a global construction company that is using this on a project. Unfortunately, the product is sanitized, but we'll have some more example afterwards. And they had a site, and they had to put in more volumes to get the numbers right, to be profitable on this site. So they put a tower in the middle, which reduced the living quality significantly across many of these apartments. So they used Spacemaker to come up with a solution that kept the overall concept that they initially wanted by packing smarter. So they only increased the average height by 2 meters. It's within the zoning, but they added 5,000 square meters. And they increased the living qualities. The darkest apartments, the densest apartments were better. So there actually wasn't a trade-off. And this is what it's about. this is what computers can do when they test billions of solutions. And I'm lucky to have one of our customers here with me on stage, the CEO of one of the larger developers in our region. He, like us, shares our vision of designing more sustainable buildings and cities. He's at the advisory group of UN's office in Europe, and he's with us today to tell us his experiences of using this technology.
Thank you. Can you hear me? Is it on? Yeah. It's not the US. Yes. No, I sit on the real estate advisory board in Geneva, representing the Nordics. And what we try to do is to share information and share technology within the UN community, which I think is great. I'm from the private sector. I'm a property developer in Oslo. We do large city urban projects. And we have been working with Håvard and Spacemaker since 2016. We've been working closely together to develop the program and to test it on our projects. We think it's a great program. We think it's a great tool. It's a fantastic tool when you do a development project, and especially in the early feasibility studies. So what we do is we use Spacemaker when we go into an area. Most of our projects are large-scale city developments, urban areas, several blocks or larger areas where you have to do a lot of different research and studies on the site. And what we can use, what we can do with the Spacemaker is that it gives us an instant overview of the possibilities of the site. And a normal approach will be to have either an architect competition and go the traditional way, and you don't really know what the right solution is. If we do use Spacemaker in the early stage, it's fact-based information that you get very early. So what we do, we use Spacemaker very early. We do all these design proposals ourselves, or feasibility studies ourselves, and that gives us a lot of fact and information on the property. And then afterwards, we go out and have an architectural competition. So it's important to say that this program does not replace the architect. I think a lot of architects say that this is kind of a scary technology. It is not. It's the combination that is really, really good. And I will show you some pictures about that. So we dive into this program, and as Håvard and Ingvild showed us earlier, you can do a lot of different testing on height, on density, on noise reduction, and the sun and quality of the apartments. So we do all these feasibility studies very early, and that gives us an approach, and it gives us the facts. We know more or less how this development is going to look like. And then we give this file, we give all this information to the architects, and then we have a traditional architect competition afterwards. And the combination is really good. So we did this on a site development outside of Oslo. It's the city center of a new, it's one of the cities close to Oslo, which is totally being changed due to urban transportation and sustainability goals, where you are redesigning all these city hubs with a much higher density. That's kind of what we specialize on. So the program gave us this solution, which is more or less the maximum density and the best solution, fact-based, in Spacemaker. And after the architect competition, this is what it looked like. And interestingly, we invited 4 of the best architect companies in Oslo or in Norway to be in this competition. And 3 of them, they were skeptical about this. They wanted to do the traditional way. So they believe that they as architects, they are the best to kind of develop and look like how this site is going to be developed. So they chose to go another way. But one of them chose to look at the fact, and they used the time they saved on on using the Spacemaker fact-based information. So they didn't have to do the sunlight calculations or the noise calculations. They went directly into the model, and they spent all their time on doing the architectural stuff. You know, the stormwater problems, the green roof, the materials in the facades, making sure that all these small rooms in between are really nice. And they changed the buildings a little bit to improve the quality. So the result and what they proposed to us was this company was way better than the other ones because they used the fact from the Spacemaker model. Huge difference. So yes, I think Spacemaker gives us a tool that improves the process a lot. It's way quicker. It's a fact-based information for us as developers, and it gives us a lot better starting point for the architects to start. And I think also one of the biggest benefits also is that we have fact-based information. It's a communication platform that we can use into the municipality and when we want to rezone the area. Because it's all fact-based. We can prove it by using the model. I think that is it.
Okay, great, thank you. So, thank you, Mathis. I will just sum up then. I want to just remind you of why we're doing this. Our vision and our mission is that we believe that we can build a new technology that can break down the silos, that can enable a collaborative workforce. Mathis is describing one way of using this, and we see other customers who use it in a different ways. We see architects using them, we see internal architects, external architects, or developers, but it's about democratizing these specialist tools, right? It's about merging them all together so that you can discuss over a common platform and do those intelligent trade-offs together. That's what we're doing. And if you want to learn more and figure out how can you use this, what can you use it for, we're down here at booth 16. So you can come down, have an in-depth demo, or ask, like, how can this be applied? But there are some key points here that I want to stress when it comes to how can you use this? You can start by using this on feasibility studies. You can eventually work on different use cases across sub-verticals. We're starting with residential, but we're going into planning office buildings, hotels, hospitals, roads. And the industry is adopting this. You saw some logos. We have more. The first movers is starting to adopt this new technology. And we want to spread that best practice, to tell you how you can use this. That's our job. How can you actually use this? And to tell you how these small improvements can have a big financial impact, but also environmental impact on how you design. So please come down, visit us at stand 16. Thank you for listening.
Okay, thanks very much, Håvard. Really, really exciting stuff. I think we can all agree we've seen something really exciting there, and the potential, the cogs are whirring of where development and AI can go designing in the future. We are running behind, but there is a lot of interest in what Spacemaker are doing and AI in design for development. So if there are any questions, please, we will take a couple now. Put your hands up, and this is your chance to get some free advice on how AI works, or ask the stupid question about how the computerized tool reads those data sets. If not, then as you've heard, there's a stand downstairs, and they're around all day to take questions and meet up with people. So I'm seeing absolutely no hands whatsoever go up. So okay, there's one over there. We'll take that.
Are you collaborating with search providers? So I'm in the legal industry, and we're seeing a lot of search providers building on data networks and layers of data. Is that part of your product? Are you tapping into the huge amount of data that's already there about sort of environmental history of the site and that kind of thing, or is that not part of your product?
Well, that's a big question, and I'd love to elaborate more on the stand, but I guess the simple answer is that we are building a technology that can handle a rich variety of data. So it's really about what kind of data you want to use it for. Yeah.
Okay, one other question there. There is a mic coming.
Yeah.
And then we'll close.
Hello, Jerne Widmar from Gili City. I have a question regarding the zoning regulations that you obviously need to input into your machine. So how do you do it maybe, and what cities do you currently support maybe, or are you already expanding also in this field of covering more cities, because each of the city has different set of rules?
Yes, good question. We're solving a global problem, and we're currently the product is being used across different markets with completely different zonings. So we see that it is possible because the user inputs a lot of the kind of unique local stuff themselves, and it goes really fast. But it's a good question, but we can deep dive into which regions we are now at the stand. Obviously, most of our users are in the home market where we started, but we're spreading out, yes.
That's amazing. We'll continue that conversation back in the main hall. Join me again in thanking our speakers.
Thank you.